Students, good afternoon. Standard 11, subject chemistry. Dear students, in 11th standard chemistry, we are dealing with unit number 1, which is basic concepts of chemistry and chemical calculations. And in that unit, various topics we have seen so far. And today, in this video, the concept which we are going to discuss is stoichiometry calculations. Dear students, it is an entirely new concept for you. Okay, so please pay attention and try to understand what I am coming to explain. If you have any doubt, you can immediately contact me and get clarified with your doubts. Okay, so what is the concept of today's video class? It is stoichiometry calculations. First, we have to know what is called as stoichiometry. Students, let me tell you a simple example. See, if you want to prepare any food items, in your book, the preparation of kesari is given. So for preparing kesari, we need rava, water, nuts, ghee. So those are the ingredients we need to prepare a kesari. But depending upon the quantities only, we can calculate the amount. For example, if you want 4 cups of kesari, at least we have to take 2 cups of rava. Isn't it? Yes. The same technique is employed in industries to determine the quantity of reactants required to a particular amount of product. So the calculations involving in such areas to calculate the quantity of chemical entities which are required to prepare a certain quantity of products is termed as stoichiometry calculations. Okay, Mama? Okay, first let me tell you the meaning of the term stoichiometry. Look here. So this stoichiometry is a word which is derived from Greek language. In Greek, stoichion means element and metric means measure. So there is a measuring calculations about the quantity of element is called as stoichiometry. So it is a Greek word. It is a combination of two words. Those are stoichion and metric. What is stoichion meant by? It means element and metric in the sense measure. Okay. So now come here. This is the definition of stoichiometry. Stoichiometry gives the numerical relationship between chemical quantities in a balanced chemical equation. In a balanced chemical equation, the numerical relationship between the chemical quantities is given by the term stoichiometry. As I told you already, to prepare a particular amount of product, how much amount of reactants are required. Such calculations can be made by stoichiometry. Okay, now come here. By applying the concept of stoichiometry, we can calculate the amount of reactants. This I already explained. Let me read and tell you. By applying the concept of stoichiometry, we can calculate the amount of reactants required to prepare a specific amount of products and vice versa. Okay, and in a balanced chemical equation. So that is called as stoichiometry calculation. Okay, now look here, next slide. Look here, consider the following reaction. Here there is a preparation of carbon monoxide is taken. How carbon monoxide is prepared? When carbon reacts with oxygen, the product is, not carbon monoxide, carbon dioxide. When carbon reacts with oxygen, the product is carbon dioxide. Look here, C reacts with O2 and forms CO2. Here, in front of each chemical element, for example, in front of carbon, what is there? In front of carbon, 1 is there. So we can say 1 mole of carbon. In the same way, in front of oxygen, what number is there? It is 1. So we can say 1 mole of oxygen. And in front of carbon dioxide, what is there? 1 is there. So how to read this equation is 1 mole of carbon reacts with 1 mole of oxygen and forms 1 mole of carbon dioxide. So dear students, this is the actual way of representing or reading a chemical equation. We should not simply read carbon C plus O2 gives CO2. That is not the actual way of reading a chemical equation. We have to read it as 1 mole of carbon reacts with 1 mole of oxygen and forms 1 mole of carbon dioxide. Actually, that is the right way of reading a chemical equation. Is it clear, students? Now, those numbers I told you about 1 mole of carbon, 1 mole of oxygen, no? So those can be called by the term stoichiometric coefficients. Okay, so the numbers in front of each chemical term is it can be called as stoichiometry coefficients. Is it clear, students? What are stoichiometry coefficients? The number written in front of each chemical term in a chemical equation is called as stoichiometry coefficients. So how to read this equation? 1 mole of carbon reacts with 1 mole of oxygen and forms 1 mole of carbon dioxide. Okay, mama? Okay, now come here. The next slide. We are going to see what is called as stoichiometric calculations. So as I told you already, the same thing we are going to repeat now. Read it. Stoichiometry is the quantitative relationship between reactants and products in a balanced chemical equation in moles. Okay, so we have to represent the relationship between the reactants and products in terms of moles. Just now we have seen 1 mole of carbon reacts with 1 mole of oxygen and forms 1 mole of carbon dioxide. So stoichiometry is a quantitative relationship between the reactants and the products in a balanced chemical equation, and here the terms are expressed in moles. Okay, okay. Now what is given here? The quantity of reactants and products can be expressed. There are 3 different ways of expressing the quantity of reactants or products, and those are moles. We can say either in terms of mole, 1 mole, 2 mole, and so on, or in terms of mass. We can say by mass, 14 gram of nitrogen, 12 gram of carbon. Likewise, by their mass we can represent them. Also by volume, 1 volume of carbon, 1 volume of oxygen. So there are 3 terms employed for representing a chemical equation. Those are number of moles, mass, and volume. Okay, look here, these 3 terms are interconvertible. The terms mass, number of moles, and volume, those terms are interconvertible. Look here, how mass can be converted into number of moles. How it is possible? We know one formula. Number of moles is equal to mass divided by molar mass or molecular mass. So that is given here. When mass is divided by molar mass, we will get number of moles. Okay, then how number of moles can be converted into volume? We know that 1 mole of any substance can occupy 22.4 liters. Isn't it? In 10th standard itself we have seen what is called as molar volume. 1 mole of any substance can occupy either 22.4 liters or we can say 22,400 milliliters. You all remember? Yes. Okay, so when number of moles is known, it can be converted into molar volume by multiplying with 22.4. Okay, now we can see the reverse one, how volume can be converted into number of moles. When the molar volume is divided by 22.4, you can get the number of moles. Then how number of moles can be converted into mass? When it is multiplied by molar mass. Okay, so these 3 terms, the mass, number of moles, and the volume can be they are interconvertible. Okay, so what we have seen here, the quantity of number of moles or the quantity of reactants or products can be expressed in 3 different terms. Those are number of moles, mass, and volume, and those 3 terms are interconvertible. Okay, okay. Now in order to explain this, we have an equation. Look here, an equation is taken, that is CH4, methane. How to read this equation? 1 mole of methane reacts with 2 moles of oxygen and forms 1 mole of carbon dioxide and 2 moles of water molecule. This is the actual way of reading this equation as I taught you just now. Is it clear, students? Yes. Now for this equation, the entire things we are going to explain now. First, what is given? Stoichiometric coefficients. You know about stoichiometric coefficients. See here, methane, oxygen, carbon dioxide, and water molecule. For methane, what is the stoichiometric coefficient? It is 1. And for oxygen, what is the stoichiometric coefficient? It is 2. And for carbon dioxide, the stoichiometric coefficient is 1. And for water molecule also, the stoichiometric coefficient is 2. Then second one, mole relationship. How to read this equation? 1 mole of methane reacts with 2 moles of oxygen and forms 1 mole of carbon dioxide and 2 moles of water molecule. So this is the mole relationship. Reactants are also expressed in moles and the products are also expressed in moles. How to read this equation in terms of moles? 1 mole of methane reacts with 2 moles of oxygen and forms 1 mole of carbon dioxide and 2 moles of water molecule. Okay, va? Okay. Then mass relationship. Next one is what? Mass relationship, which means the reactants also have to be mentioned in terms of mass, and the products also have to be mentioned in terms of mass. Okay, so look here, CH4. How to find the mass of CH4? Atomic mass of carbon plus atomic mass of hydrogen. Atomic mass of carbon is 12, and for hydrogen it is 1. 4 into 1 4, so 12 plus 4 is equal to 16. So we can say 16 gram of methane reacts with 64 gram of oxygen. Generally the mass of one oxygen is 16. Here 4 oxygens are there. 2 into 2 4, so 4 into 16, that is equal to 64. So we can say 64 gram of oxygen reacts with carbon dioxide. The molar mass or molecular mass of carbon dioxide is 44, so 44 gram. Then for water molecule, the molar mass is 18. Here 2 water molecules are there, so 2 into 18, 36. So how to read this equation in terms of mass relationship? When 16 gram of methane reacts with 64 gram of oxygen, it forms 44 gram of carbon dioxide and 36 gram of water molecule. Okay, so this is mass relationship. Then next one is, sorry, the same thing is given here. These two terms are the same. Okay, then finally volume relationship. We have to represent in terms of volume. Look here how many number of moles are there? Only 1 mole. How to get the volume? When the number of moles is multiplied by 22.4, you can get the molar volume. Here 1 mole is there, no? So we can say 22.4 liters of methane. Here how many moles are there? 2 moles. Oxygen 2 moles. So 2 into 22.4, 44.8. Then carbon dioxide only 1 mole, so 22.4. Then hydrogen 2 moles, so 2 into 22.4, 44.8. It's there. Okay, then how to read this equation in terms of volume relationship? When 22.4 liters of methane is allowed to react with 44.8 liters of oxygen, we get 22.4 liters of carbon dioxide and 44.8 liters of water molecule. So dear students, this is the table given to understand. We can express the reactants and products in various units such as number of moles, volume, as well as mass. Okay, okay. So with this concept is over. Then we can have an example problem, stoichiometry problems. There are 4 problems are there. Here I will explain only one problem. Remaining I will give you as a homework. Okay, look here. Look the first problem. What is given? How many moles of hydrogen is required to produce 10 moles of ammonia? Dear students, whenever we have to solve problems based on stoichiometry, we should know the balanced chemical equation. Without knowing the balanced chemical equation, we cannot solve a problem based on stoichiometry. So for solving this problem, we have to be familiar with the chemical equation which represents the synthesis of ammonia. We know that when nitrogen reacts with hydrogen, the product is ammonia. Look here, it is the balanced chemical equation. N2, 1 mole of nitrogen reacts with 3H2, 3 moles of hydrogen, and forms 2NH3, 2 moles of ammonia. So how to read this reaction? When 1 mole of nitrogen reacts with 3 moles of hydrogen, the product is 2 moles of ammonia. Okay. Okay, so from this equation we came to understand that, look here, the product is 2 moles of ammonia, 2NH3. So to prepare 2 moles of ammonia, how many moles of hydrogens are required? Look here, 3 moles of hydrogens are required. Understand very clearly. To prepare 2 moles of ammonia, 3 moles of hydrogens are required. Okay, then to prepare 10 moles of ammonia, so what we have to do? Look the calculation here. 2 moles of ammonia can be prepared from 3 moles of hydrogen. Then we need 10 moles of hydrogen, means it has to be multiplied with 10 moles of ammonia. Is it clear? To prepare 2 moles of ammonia, we need 3 moles of hydrogen. Then to prepare 10 moles of ammonia, this term has to be multiplied with 10 moles of ammonia. So the answer is 15 moles of hydrogen is required. One more shortcut is there. That shortcut is, look here. Here 2 moles of ammonia is there, but we need 10 moles. How to get 10 moles? When this whole equation is multiplied by 5, we will get 10. The equation will be 5N2 plus 15H2 gives 10NH3. So in this way also we can solve. Okay, so to get 10 moles of ammonia, we need 15 moles of hydrogen. Just if we think, we can answer it. This is the normal calculation, but this is the short trick. The place of 2 has to be replaced by 10 by multiplying the entire equation by 5. Okay, so with this, the stoichiometry problem over. Okay, so here what are the things we have seen so far? Stoichiometry calculations. We have known what is called as stoichiometry and what is called as stoichiometry calculation. Then how to represent a chemical equation in terms of mass, in terms of number of moles, and in terms of volume. And for a chemical equation, we have seen all those representations. And finally, we have seen a stoichiometry problem. The remaining problems will be given as homework. Okay, students, you can watch the video twice to have a clear and better understanding. Thank you.